Hello everyone and welcome to this presentation on cryptography. Cryptography at its core is the science and art of securing information by transforming it into a form that is unreadable to an authorized individual. So the term itself comes from Greek meaning secret writing, and it's been used for centuries to protect sensitive information from prying eyes. So in today's world, cryptography is everywhere, from securing our online banking transaction to protecting our private messages on social media. So the main goal is to ensure that even if a message is intercepted, only the intended recipient who has the right key can read it. So as a technology evolves, so do the methods used by attackers, making cryptography a constantly advancing field. Then when we're talking of steganography, this is something you can call hidden in plain sight. So while cryptography focuses on making a message unreadable, steganography takes a different approach. It hides the very existence of the message. The word steganography means covered writing, right, in Greek. Imagine sending a secret message not by encrypting it, but by concealing it within an ordinary looking image, audio file, or even a network protocol. For example, you could hide a text message inside the pixels of a digital photograph so that anyone looking at the image would see nothing unusual. Right. So this technique is especially useful when you want to avoid drawing attention to the fact that you are communicating in secret. So both cryptography and steganography aim to protect information, but they do so in fundamentally different ways. So we need to define a few terms that we'll be using during the course of learning of cybersecurity. Specifically cryptography. So we need to explain plain text and ciphertext. So plain text refers to information in its original readable format. So for example, an email you write before it's encrypted is in plain text, right? So this is also called a clear text, language that we normally use, that is easily understood by everyone. Then when you are talking of ciphertext, on the other hand, is the result of applying an encryption algorithm to plain text, rendering it unreadable without the correct key. So this transformation is essential for maintaining confidentiality. For instance, if you would encrypt the message "Hello World" using a cipher, the output might look like a random string of characters, completely meaningless to anyone without the decryption key. This one is an example of a plain text and a ciphertext. Then this hi Amit, hope you are doing fine. How about meeting at the train station this Friday at 5 p.m.? Please let me know if it is okay with you. Regards Atu. This is plain text message, and you can see that the corresponding ciphertext message is looking like a chain or a random string of characters that you can see as meaningless, and it's looking completely meaningless to someone without the decryption key. So to see its meaning, you need to make use of a decryption key so that you can be able to read the message that is labeled plain text message. Then also need to define encryption and decryption, right? Then when you're talking of encryption, this is the process of converting plain text into ciphertext using an algorithm and a key. Decryption is the reverse process. That's turning ciphertext back into plain text using an appropriate key, right? So these processes are fundamental to secure communication. For example, when you send a message via WhatsApp, your message is encrypted on your device and only decrypted on the recipient's device, ensuring that even if the message is intercepted, it remains confidential. Then also need to see the types of cryptography that we have. There are two main types of cryptography. We have a symmetric key and asymmetric key. In symmetric key cryptography, the same secret key is used for both encryption and decryption. This is symmetric key cipher. So we are saying that the same secret key is used for both encryption and decryption. So this method is fast and efficient, but the challenge lies in securely sharing the key between parties. So a classic example is the advanced encryption standard, the AES, right? So if you look at the key that is used by Alice, that's the same key that will be used to decrypt the algorithm. The key that is used to encrypt by Alice is the same key that will be used to decrypt by Bob. If we check at the diagram on our screen. Then in asymmetric key cryptography, also known as public key cryptography, two keys are used, right? A public key for encryption and a private key for decryption. So this allows secure communication without the need to share a secret key. RSA is a well-known example of this approach. So Kirchhoff principle, this is another concept, another principle that we need to discuss. So this one is a foundational concept in cryptography, right, which states that the security of a cryptographic system should depend only on the secrecy of the key, not the secrecy of the algorithm, right? So this means that even if an attacker knows the algorithm being used, they should not be able to decrypt the message without the key, right? So this principle encourages the use of well-tested, publicly scrutinized algorithms rather than relying on security through obscurity. So this marks the end of our presentation on cryptography. This is the introduction where we explained, we defined key terms that we'll be using during the topic of cryptography. So we introduced cryptography, the definition of cryptography, the definition of steganography, and the difference between steganography and cryptography. Then we moved on to explain the terms that we'll be using, that is plain text, ciphertext, encryption and decryption, then the types of cryptography, then the Kirchhoff principle. So this marks the end of our introductory lecture on cryptography.